Let's talk about strategies for setting up an integration by parts problem. When we're solving an integral using integration by parts, we try to look at the integral as a form, the integral of u times dv. We pick part of the integrand to be u, and everything remaining is automatically dv. Then we apply the integration by parts formula and go from there. But how do we start? How do we choose which portion of the integrand will be u? Well, we have a handy little guideline here called LIATE. This acronym helps us to determine which function we should pick for u. This is not a hard and fast rule. This is not guaranteed to work in every situation. But for most of the problems we see in Calculus 2, following this guideline for integration by parts will be effective. So if we think integration by parts is the correct integration technique, but we don't know what to choose for u, we should look for the following functions. First, we should determine if there's a logarithmic function. Next, we look for an inverse trig function, then an algebraic function, finally trigonometric, and then our last choice is exponential, L-I-A-T-E. All right, something we want to be careful about here. We use the variable name u for integration by parts, and we also used the same variable name when we did substitution. These two u's for integration by substitution and for integration by parts are completely different concepts. This LIATE is a guide for integration by parts only. It is not for u substitution problems. We use u in completely different ways for these two different techniques. So even though we're using the same variable name, don't get the u for integration by parts confused with the u for u substitution. All right, with this in mind, let's just look at the first two examples that we did, which were the integral of x e to the x and the integral of x times natural log of x. And we'll think through the acronym LIATE. When we solved example 1, we chose u to be x. X is an algebraic function. Another algebraic function could be something such as x squared or square root of x. Any expression like that, maybe a rational function, those are all algebraic functions. In the second example, we chose u to be the log function. That's what L stands for. So in general, L stands for a log function, such as natural log of x. The I stands for inverse trig, and this could be potentially arctangent or arcsine, something like that. T is for trig. This could be either sine, cosine, tangent, something of that form. And the last resort, E, this is exponential, generally e to the x. All right, let's work through a couple more examples using this strategy, LIATE. Take a look at example 3. We have the integral of x squared times sine of x. All right, to solve this problem, we need to choose something to be u, and everything remaining in the integral will be dv. Now, how do we pick u? Let's follow the acronym LIATE. We first look for a log function. There are no log functions in this integral. Next, we look for inverse trig. Well, we have a trig function, but there's no inverse trig functions. The next letter is A. A stands for algebraic. We do have an algebraic function, x squared. So we will choose u equals x squared. We're not guaranteed that this will work, but it's a good rule of thumb. So let's try it. If u equals x squared, dv is everything left, which is sine of x dx. Now we take a derivative to find du. The derivative of x squared is 2x. And we integrate to find v. V is the integral of dv. The integral of sine is negative cosine of x. We have u and v. We are ready to use the integration by parts formula. We take u times v minus the integral of v, which is negative cosine of x, du. Du is 2x dx. All right, now this integral that we have, I have negative, negative, so Let's convert that to be positive. And this 2 is a constant factor that I can bring out in front of the integral. So our expression becomes x squared times negative cosine of x plus 2 times the integral. And for me, I like to write the x at the start of the integral. So I took the 2 out front, and I'll write x times cosine of x dx. Before we're finished with the problem, we need to solve this integral. Now, this integral, this looks like another integration by parts problem. And in fact, it is. So for this particular example, we are applying integration by parts twice. Let's try that for this second integral here. I'm going to use u and v once again, even though they're different values for u and v. Let's choose u to be x. That's the algebraic function. dv is everything left, cosine of x dx. Take the derivative of u, the derivative of x is 1, so du equals dx. We integrate dv. The integral of cosine is positive sine of x. And now we're ready to apply the integration by parts formula to this second integral. So our expression is x squared times negative cosine of x plus 2 times the quantity. Now we'll use integration by parts formula again. We have u times v minus the integral of v du. In this case, du equals dx. We're almost done with the problem. We just have to evaluate this final integral. Antiderivative of sine is negative cosine. That will cancel with this negative. So our final answer, we copy down everything else that we had. X sine of x minus minus cosine, so plus cosine of x plus c, and that is the correct answer. We could check by taking the derivative of this expression. You should take a couple minutes to do this on your own, and you'll see that the derivative of that expression is x squared times sine of x. Let's work through example 4. For example 4, we have the integral of natural log of x dx. We will solve this using integration by parts, and again, we're trying to view this integral in the form the integral of u dv. Something that's a little bit different with this particular problem is that we only have one factor in the integrand. In all of the other examples that we've done so far, we had multiple factors in the integrand. Here we just have natural log of x in the integrand. We can still solve it using integration by parts, and let's see how that's done. The first step is to choose something to be u. We will use our acronym LIATE. L is for log, and we have a log function. So we will choose u equals natural log of x. dv, by default, is everything remaining. That's dx. So we take a derivative. The derivative of natural log of x is 1 over x dx. And now we find v by integrating dv. Well, that's just integrating dx. This might look a little bit strange, but we're really just integrating 1 times dx. What function has a derivative of 1? It's simply x. So that is v. So the integral of natural log of x, using integration by parts, we have u times v minus the integral of v du. du is 1 over x dx. Notice how nicely this second integral simplifies. X divided by x, that's simply 1. So we have natural log of x times x minus the integral of 1, which is just x. Tack on a plus c, and we have our answer. Let's go ahead and check this answer. Notice when we check that we will use the derivative rule for a product in order to find the derivative of natural log of x times x. So we take the derivative of natural log first, that's 1 over x, multiply by the second function x, add on natural log of x times the derivative of x, which is simply 1, and we subtract the derivative of x, 1. 1 over x times x simplifies to 1, plus natural log of x minus 1, and we're left simply with natural log of x. We know that our answer is correct. The derivative is natural log of x. Let's take a look at example 5. We have the arctangent integrated from 0 to 1. Thinking of our acronym LIATE, we look first for a logarithmic function, and we don't see any, so we look next for an inverse trig. Arctangent is inverse trig. So we will choose u equals arctangent of x. Everything left over is dv, so dv is dx. Now we take the derivative of u. The derivative of arctangent is 1 over 1 plus x squared dx. Now, this is a relationship that we want to be comfortable with. The integral of dv is simply the integral of dx, which again, we're integrating 1 dx, so this is simply x. Now, we use the uv minus in the integral of v du formula. U v minus the integral of v times du, 1 over 1 plus x squared dx. At this point, we still need to evaluate this resulting integral. And this looks rather complex. We have x times 1 over 1 plus x squared. How do we deal with that? Well, we will deal with this using integration by substitution. That's right. We are going to use a substitution technique within an integration by parts integral. We will use u equals the denominator here in order to solve this integral using substitution. We'll use the same variable name u, but we need to understand that it's different from the u that we chose when doing integration by parts. So we choose u equals 1 plus x squared and follow the steps for substitution. We take the derivative of u, which is 2x, solve for dx. Dx equals du divided by 2x, and now we're ready to substitute. We copy down arctangent of x times x minus the integral of x times 1 over u, and now dx turns into du divided by 2x. This is useful. The x's can be canceled, and this 2 in the denominator can be taken out front as 1/2. So we have arctangent of x times x minus 1/2 times the integral of 1 over u du. The antiderivative of 1 over u is the natural log of u. So we have natural log absolute value of u, and I'll just go ahead and write u as 1 plus x squared. Now this is the antiderivative of arctangent of x. So we have our capital F of x here. We started with a definite integral, so we bring back the limits of integration at the end of the problem, integrating from 0 to 1. First we'll plug in a 1, then a 0, take the difference. Arctangent of 1 times 1 minus 1/2 natural log of 1 plus 1 squared is 2, minus, in parentheses, 0 times arctangent of 0, so that term will go away, minus 1/2 natural log of 1 plus 0. Natural log of 1 is 0. Both of the terms here in this parentheses, these are 0, so our final answer is this right here.